Hi, welcome to the pre-calculus lecture series. And we are in the section 2.6, transformation of functions. And this is our video number 2. On the previous video, we did several transformations. We talk about vertical shifting, so it's go up and down the y-axis. And then we also talk about the horizontal shifting, and also we talk about the reflecting of the graphs here. So in our second video, we're going to talk about another two different type of the transformations. Then we're going to also cover the one very special function. We call it even and odd functions. What is their definitions here? All right. Okay, so now I'm going to go to our worksheets here. Okay. All right, so this is a worksheet. This is what we did. We stopped at video number 1. Yeah. Okay, now let's go ahead and start. What is the vertical stretch and the shrink here? Okay, so the vertical stretch and the shrink is like this. Okay, so like in here for the graph, okay. Okay, so y equal to c f of x. So if you times the constant of this graph, so we know if c greater than 1, okay, then we stretch. So we stretch the graph vertically by our factor of c. Okay, so if the c is between 0 and 1, so that means we shrink the graph of y equal to the f of x vertically by a factor of c. So it's kind of a common sense, right? That means if it's greater, that means every value of the y, you times this constant. That's why I make it so if it's times 2, so every value of the y going to be twice as what the original numbers, right? So let's take a look here. Let's see what do I mean here. So let's see here. Okay, so okay, so if I have a functions, so let's see here, these functions. So this is my original function. So this is my f of x. So if I times everything greater than 1, so if, for example, I times 1.5, right? That means all this point are going to be 1.5 times the original point. But for those points at the 0, right? So at the 0, you times 1.5, still 1.5, right? So that's why your graph is going to look like something like this. Right, so the red ones here, this is, we say, y equal to the c times f of x, because the c is greater than 1. So that means, you know, the whatever the points here, you times that factor. But now, of course, when they touch the x-axis, right, so it's 0. So it's still 0 times and still 0, right? So that's why they will need to add the x-axis here. Okay, so this is why we call it is the stretch, right? So did you see that? So that's why we stretch here. So we kind of make it kind of longer and bigger, something like that. Okay, so now let's take a look here. So for this functions here. So it's the same ways here. If this is my function, okay, so this is the blue one is my f of x. So now if you times something like it's less than 1, let's say 0.5 or 0.7, that means all these values are going to be lower, right? Because you times the factor 0.7, 0.5. So that will be your function for this going to looks like. So this one's here, this is f of x, y equal to the c, f of x, and c is from 0 and 1. So as can you see here, it's kind of like you push, you squeeze, you squeeze your f of x. So that is what we call this is a shrink, right? So it's kind of you push it tighter here. Okay, so now let's take a look at some examples here. All right, so this is the examples here. So this is our favorite parent function quadratic again. Yay. Okay, so now let's take a look at what is the graph going to look like. All right, so here, so we say we have x and x squared. 0, 1, 2, negative 1, negative 2, right? 0, 1, 4, 1, 4, right? Okay, now let's take a look at the start. Always start with the what? The parent function, right? So it's 0 here, right? 1, 1 here, negative 1 here, 2, 4, and negative 2, 4 here. Okay, this is our parent function. So use what? Use dot, because that's not my final product, right? Okay, so now let's take a look at the 3x squared. Okay, so the first point is here, right? So 0 times 0, 3 still is 0. Okay, the second one is here is y is 1. Now you times what? You times 3. So what is this point go? Boom, this point go to here. Correct? Then this one here is negative, 1 again. So what is this point go? This point go here. Okay, so now let's take a look at this point. This is 4. You times 2. Oh boy. So what do you go? You go to 12 here. Oh, it's outside my graph. So this is 2 here. You go to outside here. All right. So now you can connect it with a solid. Right, so this is the 3x squared. So as you can see, it's kind of like a what? You kind of stretch that, right? So kind of like you use a rubber band, you kind of stretch it. Okay, so now let's take a look at the 1/3 x squared. The 1/3 x squared, when x equal to 0, still here, right? Okay, x equal to 1, so times 1/3, this graph is really small here, right? So it's somewhere here, then here is somewhere here. Then this is 2. 1/3 is 4 divided by 3 is a little bit over 1. So it's this point drop to here, and this point drop to here. Correct? Okay, now here, look here. This is what is your, right? So this is 1/3 x squared. So what is that looks like? That is kind of like say, hey, you kind of push like you smash your parent function, right? And then you push it down. So that's why we put it is the shrink here. Okay, so that's it. And now the number 6, this one here is a very good one. It's a combine all the things we learned so far. Let's see if we can get it, right? So we still start with what is x squared. So what is x squared means here? That means the parent function, right? So let's start with the parent function here. So this we write many times already. Okay, so you always have your parent functions 1, 4, 1, 4. Okay, so let's start out with the parent, right? Okay, so 0, 0, 1, 1, negative 1, 2, 4, negative 2, 4 here, right? So you go boom, 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 boom. So you do the dot lines here, right? Okay, so now the next thing is we want to do is what? Remember the order of the operation. So the next thing we want to do is, hey, take a look at the shift here. All right. So the shift here, so this is x minus 3, right? So x minus 3, so we said x minus 3 equal to 0, so x equal to 3. So what's that mean? That means I shift to what? I shift to the right 3 units, okay? Let's see here. So this unit shift to the right, shift to this unit. This point is here, shift to the right 3. 1, 2, 3, so shift to here. This one shift to the right, 1, 2, 3, so shift to here. This point, 1, 2, 3, shift to here. 1, 2, 3, shift to what? Here, right? So this is this operation, okay? So still, this is dot lines, right? Because I have not, right, finished my operation yet. Okay, now the next things here, I need to do here, right? Times, right? So the times, I need to times what? Times 2 here, right? So the times 2 here. Now I'm going to run out my colors here. So, okay, so let's try to use the same color here. So times 2. Okay, so 2, so this point times 2 still, okay, still be here. Let me use maybe this, okay, so this one times 2 still be here, right? Okay, this point is 1, you times 2, where that point go? Go to the where. So go where is 2 here, right? So this is 1, go to 2. Then this is what? This is 4. You times 2, go all the way to where? Go 8, right? So this one's here. So this point go where? Go 8 here. All right. So now you can connect those points here. So it's 2 is here, right? So I'll go here. So it's a dotted line here, right? So you see here. So this is the still is the dotted line. Now the next things here, I have this negative. So what I need to do? Okay, I need to flip, right? So flip over what? Y-axis, x-axis. So this point is here. This is 2, so I flip down to -2. This flip down to the what? -2. This one is 8, so I flip to where? -8, right? I flip to -8 here, okay? And this one I flip to -8. Okay, so this is my, I gotta still continue, so I'm not finished yet, right? So now this one's here is all the way to -2 x minus 3 squared. Okay, so my final ones here. What is my final ones here? I need to add 1. So what's that mean? That means go up ones, right? So, okay, so let's see here. So this one's here, this point go up to here. This one go up to what? Go up to here, right? Right? This one go up to here. Okay, so 8 go up to where? Go up to 7, right? -7. So here, okay? So now this is finally, this is my final answers here. The red one is the f of x, right? So the red one is f of x is equal to the 1 minus 2 x minus 3 squared. All right, so that's what you need to do. You go to the step by step, right? Okay, so that's it. Okay, so now the one last transformation is a horizontal stretch and shrink. This is the one typical, a lot of students get confused about it. Okay, so the graph here is kind of go in the backward thinking, all right? So if I have y equal to the f of x, cx, all right? So if the c greater than 1, then we going to shrink the graph y equal to the f of x horizontally by a factor of 1 over c. All right, so if c is from the 0 to 1, okay, so this is too close, all right? So here, so if c is from the 0 to 1 here, then we're going to stretch. Then we're going to stretch the graph y equal to the f of x horizontally, okay, by a factor of 1 over c here. So let's take a look here, right? Okay, so what I mean the shrink here. Okay, so here, if this is my graph here, okay, so my graph here, so this is my parent function. This is my original graph. Let's see here. Okay, so this is my f of x. So if the c is here, and that means my graph here going to shrink somewhere like this. Okay. So the way we think about that is the how much should I shrink here? So basically you say, okay, so this is CX, right? So the CX for the whole area. So you was kind of you say, okay, so the CX equal to 1. So that's why the X here will be kind of 1 over C, right? So if it's 2X, that means I shrink half of it, right? So if it's you know, if C is the between 0 and 1, if it's 1/2, so the X equal to 1 over 1/2, that means what? You kind of stretch it, right? So this one's here, so this, you know, this red one's here, this is the f of the CX, right? The C is greater than 1 here. So the same ways here, if you have another ones here, okay, so if this is my functions here, right? So this is my f of x. Then you have, you know, we talk about the stretch. It will be something like this. Okay, so this is what I call the f of x equal to the, this is f of the next cx here. Right? So this is f of cx, and the c is from 0 to 1. So it's the reason why I said backward thinking. So like people think about it like if you times something, you know, greater than 1 is kind of like to make it bigger, right? But here the reason why we say is shrink is because we want the cx equal to 1. That's right. Okay, so now let's take a look. You know, let's take a look at the following examples. From this example, you probably will get a good idea of what we try to do here. Okay, so let me, if I can do, let me get this one. It's a little bit bigger. Let me see, let me do it. Okay, that's good, all right. Okay, so now let's see here. Okay, so let's try to do the f of the 2x first. Okay, so the 2x, okay, 2x, that means the whole things here. Right now, I need to shrink, right? I need to shrink. So that means that you know, right now the x is from the 1, 2, 3, 4, 5, 6, right? So right now x is from the 1, 2, 3, 4, 5, 6, right? So now the 2x, like we said, So the 2x equal to 1, that means x need to shrink. So I know this is going to be shrink to a half, correct? Okay, so how do I shrink it? Okay, so let's take a look. So this point, right, used to be at 1, from 0 to 1. So now this point original, so I keep this one. So this is the original from the 0 to 1. You shrink to a half. So what happened to here? The x equal to what? 1/2. So this point get to here. Correct? Okay, now let's take a look at this point. Where is this point? This point is 1, 2, 3, 4, right? 4 to the 0. Now you shrink to a half. That means this point is started with where? At the 2's here. So this is my next point. And then now this one's here. Look here. This is 1, 2, 3, 4, 5, 6. So if you shrink to a half, so what is this point going to start at 3, right? So it's 1, 2, 3. So this point go to here. Am I right? Okay, now you connect it. So you will see, oh, here's the line. Right, so that is, hope this line, okay, let me see, I can get a better lines here. Okay, so, oh, it's not too good, but that's okay. Okay, so let this blue one is the f of the 2x, you shrink it to a half, right? So it's kind of like you just smash this red graph to a half, right? Okay, now let's take a look. How about the f of the 1/2 of x? 1/2 of x, that means the 1/2 of x equal to 1. That means x equal to 2. That means I need to double whatever the 2 is, right? Okay, so now let's take a look. I'm going to use the green one. So first point here, right, is 1. You double it. So where it going to be? X capital 2. So this will be your first point. All right. Now this point is 4, and you doubled it. What are going to be? Will be 8. Right? Okay. So that I need to expand this axis a little bit longer. Okay, so this is 6, 7, 8. 9, 10, 11, 12, 13. So this is 12. Okay, so this is 8. All right. Okay, so now, right? So now let's take a look at here, right? The second point here, this is 4, right? So you need to double it. So where is that go? Hey, it's 8. So this is the second point to go to here. Now the third point is here, right? So from 0 to 6 is supposed to be 6. Now what you do? You double it. So how much is that be? It's 12. Okay, so here, right? So this one's here going to here. So now the way I can graph it, so here, of course, the 0 still here, right? So here. Okay, so this one's here. I mean, this point not changes here, right? So this point is still here. Okay, so that means here. Okay, that means so this is this one. Then you connect this one. You connect this one, right? So you still, so that my line is not very straight, but you can see this is what we call the stretch here. All right, okay. So now, after we know that, then we're going to talk about one very important concept is the even and the odd functions here. Okay, so for the even and the odd function, the one way we can, identify, we have 2 different ways we can identify it, right? So the first way is here, right? So we see from the graph, right? So if you can graph it, and so for example, see here, so from the graph, if they give you the graph here, okay, so for example, if they say, hey, this is my functions. Okay, so from the graph, so in here, then you know this is what? This is even. Why from the graph? That means this function is symmetric to the y-axis here. if the problem gives you the graph, and then you will say, oh, okay, this is the even functions here because this is even because it's symmetric to the y-axis. What I mean symmetric, that means what? What I mean symmetric, that means when I fold it, you can treat it as the y-axis is what? It's like a mirror, right? So these two and these two is kind of like they are the mirror images, right? Okay, so now the next one here is this type of the function. We call it is the odd functions here. So if I have a function go like this, okay? So this function, so we say this is what? We say this is the odd function by looking the graph. Why is looking the graph here? That means this one is symmetric to the origin. Okay, so that means here is my origins, right? So it's 0, 0. So that means it's symmetric to the origin. That means if you flip this leg going down here, it will be like this one's here. So that's why we say this is all the functions here, right? But sometimes, right? So sometimes, so this is odd, is symmetric to the origin. But sometimes, you know, the function is pretty complicated. And then we cannot really see that. And so what do we do here? We use it algebraically, okay? You know, so we say we can prove it from the algebra definitions. Okay, so let's see here. So if f is even, okay, so if f is even, then we say, hey, because it's symmetric to the y-axis. So we talk about the reflections, right? So that means if it's even, then what happens here? You put an x and you put a negative x. They will give you the same things here, all right? Then the same ways here. So here, if we say, if f is odd, okay? Then we say, hey, if you put a negative x here, what happens here? It is going to give you negative f of x. All right, so this is a kind of a very important concept, right? Okay, so like I said, if you can do the graph, then that's good. And you know, if you cannot, then you will need to use the the algebra formula to do that. So some of the graphs we know is not easy to do. Okay, so now let's take a look. This function is even, odd, or neither. All right, so the f of x is so here. So let's take a look at f of x equal to the x fifths plus x. Right? So we know it's difficult to do the graph for the x fifths power plus x. So let's try to do the algebraically, right? So like say here, this is, so we substituted the negative x. Now what's that mean? We did this in the 2.1. That means every x you need to replace with what? You need to replace with negative x, correct? Right, okay. So now let's see here. So this is negative x to the fifth power, then plus negative x, correct? Okay, now the negative 1 to the fifth power. So I know the negative 1, that means you negative 1 times negative 1 times negative 1. How many times? 5 times. So the negative 1 to the odd number powers still give you what? Negatives, right? So this will give you negative x to the fifth. Then this is plus minus, so it's negative x here. Oh, well, let me factor it out. So x, so it's x squared plus x. Gee whiz, what is x squared plus x? Ah, is f of x. Oh, so I proved here, f of negative x equal to the negative f of x. Ha, so what is this function? So f of x is what? Is an odd function, correct? Okay. Okay, so now let's take a look at part B here. The part B, so the gx is equal to the 1 minus x fourth. As always, I don't know what this graph looks like. Always, let's substitute the negative. So remember the x, right? So negative, that means everything x need to be negative, right? So that's what we talked before. So this will be 1 minus. So x will be negative x to the what? The fourth power. Okay, so now this is 1 minus. So negative 1 to the even number of the powers, what are going to become? Positive. So this will become to the 1. So it's x fourth, right? Because the negative 1 to the fourth power is equal to 1, right? So that's why it's equal to 1 minus x squared. Oh boy, that's good. So what is 1 minus x squared? Is gx. Oh, so when the negative x is equal to the gx, what type of the function? We say this is a what? Is a what? So gx is an even function. Okay, so let's take a look at the last ones here. So the h of x is 2x minus x squared. Okay, as always, we always start with negative x, correct? All right, so we want to start with negative x. That means everything in here, you need to replace it with negative x. Okay, so let's see here. So this is a 2. So this is a negative x minus negative x to the square, right? So replace all the value of the x is negative x. Okay, so what here? This is negative 2x. Okay, negative x to the square. What happened? The negative 1 to the even power, what is going to be? Positive 1. So the whole this term will become what is minus x squared, right? So now let's take a look if we can factor the negative out. Okay, so this is a 2x plus x squared. Too bad. This numbers here is not equal to the h of x, right? Because h of x is 2x minus x squared. So this is not equal to the h of x. So what can we conclude? Okay, so h of x is not even number, not an odd function, so it's neither. So it is not an odd function, it's not an even function. And that's it, all right? So this section is a pretty long section here. So, but we talk about some very important concept, right, about the transformations of a function. So you can always produce the graph, start out with their parent function, then you do one transformation at a time, all right? And then until you finish all the transformations. Then the next important topic here we talk about is even and odd functions. So be very careful the way we say the even and odd function. You can have 2 ways to identify it. If the problems give you a graph, then you will see, hey, this graph is symmetric to the y-axis. When we talk about the symmetrics, that means, kind of like the mirror, right? So it's like when you fold it, when it will be the same, or not. And then the other function is symmetric to where? To the origins here. So if the problem does not provide you the graph, then you can use the algebra definitions here. So that if it's even, then if you substitute the f of the negative x will be equal to the f of x. If it's odd, if you substitute the f of negative x, it will be equal to the negative f of x. So when we try to check it's even and odd, we always start with negative x in the function, then to see which one they're going to produce. All right, that's it. That is for this section. It's a very long section, but it's a super important sections. And I hope you got a good understanding about all the transformations and the differences between the odd and the even functions. All right, that's it. And you guys have a good day, and I'll talk to you later in our next video. Okay, bye.